Welcome to Spaceverse, your portal to cosmic adventures. Astronomers have just found something hiding in plain sight. Galaxies so small, so unusual, and so red that until now we thought they only existed at the dawn of time. These mysterious objects, called little red dots or LRDs, were supposed to be relics of the early universe, tiny, compact galaxies formed just a few 100 million years after the Big Bang. But here's the twist: astronomers have now spotted them practically in our cosmic backyard, just 2.5 billion light-years away. And that changes everything. The discovery challenges decades of thinking about galaxy formation. It suggests that the strange, intense conditions we thought only existed in the universe's infancy might still happen today. This forces astronomers to rethink not only when these galaxies form, but why they form and whether they ever really disappear at all. Little red dots first appeared in the James Webb Space Telescope's deep field observations. At first glance, they didn't look like much, tiny red specks among a sea of ancient light. But their properties made them stand out immediately. They're incredibly small, just a few hundred light-years across, compared to the Milky Way's 100,000 light-year span. They glow red, a color that can come from two main causes. Either dust obscures their light, making them appear redder than they really are, or their internal processes, like intense star formation or black hole activity, are producing light skewed toward the red end of the spectrum. Their compact size and the specific emission lines astronomers detected hinted at something extreme going on inside. Many scientists suspected either a phase of rapid star formation, what we call a starburst, or the presence of an active galactic nucleus, meaning a supermassive black hole feeding on gas at the galaxy's center. What made them even more fascinating was their distance. JWST detected them at very high redshifts, meaning the light we see today left these galaxies over 13 billion years ago, when the universe was just a few 100 million years old. They were believed to represent a short-lived, turbulent stage in galaxy evolution, a kind of youthful chaos that quickly faded as galaxies grew larger and more stable. That was the prevailing theory. Until now. A study published in July 2025 identified three galaxies with nearly identical properties to those early universe LRDs, except they're much closer, only 2.5 billion light-years away. For cosmic scales, that's right next door. These local LRDs were found using data from the Sloan Digital Sky Survey and the Daisy Legacy Imaging Survey. At first, they weren't recognized as little red dots at all. Their unusual ultraviolet optical spectra made them look like potential quasars, galaxies powered by extremely bright, actively feeding black holes. But deeper analysis showed they lacked the rapid variability and other signatures that quasars usually have. Instead, their characteristics lined up perfectly with the LRD profile: extremely compact size, deep red optical color, broad hydrogen and helium emission lines, and an infrared signature that dropped off sharply. In other words, they looked almost exactly like their 13-billion-year-old cousins. That raises two possibilities. Either some LRDs can survive billions of years without evolving into something else, or the physical conditions needed to create them can still occur in the modern universe. Either way, this shakes up the idea that they are exclusively tied to the universe's earliest epoch. One leading theory is that these galaxies harbor obscured supermassive black holes, monsters feeding in the dark, hidden beneath thick clouds of gas and dust. This would explain the broad emission lines and their unusually compact structure. Another idea is that they're ultra-compact starburst galaxies, undergoing intense, short-lived episodes of star formation that mimic the energy output of black hole-driven galaxies. The exciting part about finding them locally is that now, for the first time, we can study them in far more detail. JWST's view of the early universe is incredible, but those galaxies are so distant that even the most powerful instruments struggle to reveal everything about them. Local LRDs, on the other hand, can be studied with a wider arsenal of tools: X-ray observatories, radio telescopes, optical spectroscopy, and infrared imaging, giving astronomers a much clearer picture of what's happening inside. And this isn't just about solving an astrophysical curiosity. Understanding these galaxies could rewrite our models for how galaxies grow, how supermassive black holes form and evolve, and how bursts of star formation behave in dense, compact environments. There's even the possibility that LRDs aren't a distinct type of galaxy at all, but rather a transitional stage, a brief moment in a galaxy's life triggered by a specific event, like a sudden inflow of gas or a galactic merger. If that's the case, then they're not frozen relics of the distant past, but part of a recurring cycle that plays out throughout cosmic history. So what happens now? Astronomers are wasting no time in launching a more targeted investigation. A top priority is determining whether these galaxies are hiding active black holes. So far, none of the three newly discovered LRDs show strong X-ray emissions, but that could be because the available data isn't sensitive enough. Future observations with the Chandra X-ray Observatory or XMM Newton could reveal the telltale signs of an active nucleus buried under all that dust and gas. Meanwhile, radio observations could play a key role. Telescopes like the Very Large Array in New Mexico or the upcoming Square Kilometer Array, which will be the largest radio telescope in the world, can pick up faint emissions from jets or compact star-forming regions. Radio waves can penetrate dust clouds that block visible light, making them ideal for peering into obscured galactic cores. Another step will be conducting multiband spectroscopic surveys, observations spanning ultraviolet to infrared wavelengths, to map the full energy output of these galaxies. This will help astronomers measure their star formation rates, determine how much gas and dust they contain, and even estimate the mass of any central black hole. And then there's the bigger picture, building a larger sample of local LRDs. Right now, the discovery is based on just 3 examples. By identifying more, astronomers can figure out how common they are, what environments they prefer, whether they're found in dense galaxy clusters or in isolation, and how long they remain in this unusual state. They can also investigate whether these galaxies evolve into something else we already know about, or if they're simply a stable, long-lived configuration. The multi-pronged approach, combining imaging, spectroscopy, time domain monitoring, and data from multiple wavelengths, should help answer the big questions. Are these galaxies powered by bursts of star formation, by black hole activity, or by a mix of both? Are they survivors from the early universe or newly formed examples of a process that keeps repeating itself? And perhaps most intriguingly, if the conditions to create them still exist today, how often has the universe been hiding them in plain sight? This is why astronomers are buzzing about the discovery. For decades, the story of galaxy evolution has been told as a kind of chronological ladder, starting with small, chaotic galaxies in the early universe, which grow larger and more orderly over billions of years. But finding early-type galaxies thriving in the modern era suggests that cosmic history may be less of a ladder and more of a loop, with some processes repeating again and again. The implications stretch even further. If compact, dusty, high-energy galaxies can form at any point in cosmic history, that changes how we think about the environments needed to build supermassive black holes. It changes how we model bursts of star formation. It even affects how we interpret deep field observations of the early universe, because some of the distant objects we see might not be one-time relics. They could be members of a family of galaxies that keeps appearing throughout cosmic time. For now, the 3 local LRDs are just the beginning. The search is already expanding, combing through sky survey data for other candidates that match the same compact, red, emission line-heavy profile. As the list grows, so will our ability to compare, categorize, and connect the dots between ancient and modern examples. And perhaps the most exciting part? These galaxies are close enough that future telescopes, whether on the ground or in space, will be able to study them with unprecedented resolution. The James Webb Space Telescope gave us our first glimpse of the little red dots, but now the entire astronomical community has a chance to investigate them using every tool at our disposal. X-rays, radio, optical, infrared, all working together to unravel the mystery. Little red dots just turned up in our cosmic neighborhood, and they're already rewriting what we thought we knew about how galaxies evolve. Are they ancient survivors, holding on for billions of years without changing? Or are they brand new creations, born under rare but still possible conditions? Whatever the answer, it's clear the universe still has surprises up its sleeve. The search continues, and with each new observation, we get closer to unlocking the truth. Somewhere out there in the glow of the night sky, other little red dots might be waiting to be found, quiet, compact and ready to rewrite the history of the cosmos all over again. And that's it. From the dawn of time to our own cosmic backyard, the universe keeps rewriting its story. Little red dots may be ancient relics, or proof that galaxy-making magic is still alive today. Here at Spaceverse, we'll keep chasing these mysteries because every answer only leads to bigger questions. Until next time, keep looking up. The universe is closer than you think.